All right, so now we are in week 4. Right now, let's move to the lectures. Right now, constraints. Now you know the constraint. Now we have studied several constraints in so far in this subject. So we have studied primary key constraints, foreign key constraints, and then the not null constraints, isn't it? Right. So there are so many other constraints are coming in. Now, whatever the constraints we studied, now there are two ways that we can specify the constraints in a table. Okay. For example, if you think about a constraint like a primary key constraint, we can either specify it as a column constraint or a table constraint, right? So what do you mean by a column constraint? Usually column constraint is defined when the table columns are defined, right? For example, it defined within the column definition in other ways. For example, if you go through this table, so here we are creating a table called a student table. So there are 3 columns, and then we say, so, all right, student ID is our primary key. So we define the columns, right, with the appropriate data, and then the same column we define the primary key as well, right? So in this case, the primary key is applied to one column in this table, right? Student ID. So this is called a column constraint. So it applies. This constraint applies to this column only. Okay. Sometimes we can define a constraint as a table constraints, right? Now, for example, sometimes we may have some constraints can apply to more than one columns at the given time, right? So here I have actually used the same example, but as a table constraint. Now, table constraint usually the constraint that applies to the table, we define it after we define all the columns, right? So in this case, I took the earlier example. Here the primary key I define once the column has been defined. Okay. So actually there's no difference between this and that, because it's same applies to same column. So but remember, this is the way usually we define our primary keys, but you can define in this way as well if it applies to one single column. Okay. So now here this example, I define the primary key as a table constraint, because there is one reason why we need to stick with the table constraint. Because if you have more than one column for that given primary key, remember the composite primary keys that we have studied. So the composite primary keys, we can't define as a column constraint, because in this case, this example, you can see the primary key applies to 2 columns, right? It composed of 2 columns, the building code and the room number, right? So in this case, we must stick with a table constraint way of defining the primary key, because if you put the constraints in the columns, that's totally wrong, isn't it? Because they're not. The Oracle will read it as a 2 primary keys, right? If you define it here, and if you define it the room number here, primary key, something like that, then it's wrong, isn't it? So, so the composite primary keys you need to use you need to use a table constraints. Actually, usually in what I do, I usually use the table constraints rather than a column constraints, because you can do whatever you do with the column constraint as a table constraint as well, except some other cases, special cases. Okay. But most of the time you can define any constraint as a table constraint as well, right? So I'm very comfortable with the table constraint way, because it's easy, so you can stick with that as well, right? Right. That's That's about it. And then here, this is an example. In this example, as I mentioned before, the primary key constraint here in this case are defined in both ways. So I just wanted to give this is also correct. So there is no problem about it. Right. So once you define the constraints, right? Whatever the constraint, either primary keys or foreign keys or other non-null constraints, anything, there is a way that we can check or we can access what kind of constraints we have created in our database, right? So how can we do that? By accessing the data dictionary. Remember the data dictionaries, each database keep data about data by in their own own tables, right? So in this case, the Oracle data dictionary, they keep our constraints in a table called user underscore constraints. So if we can access that table, we can actually see all the constraints we have created. Right now, this is how we accessing it. So I just run a simple select statement, select asterisk from a user underscore constraint. So this is the name of the table. Okay, so that table has bunch of actually columns. So it has a column for a owner, that is your student ID basically, in this case in the Oracle, and then the very weird constraint name. So these you don't need to actually remember the constraint name. So this is a Oracle generated numbers, but in a one day we will learn how you're going to change the constraint name, give a meaningful constraint name. So we'll learn it later on. Okay, and then we have the type of constraints. It says whether it is a primary key or it is something else, right? So in this case, we have P stand for primary key, and then C stand for another type of constraint called check constraint. And then it gives you the name of the table where the constraint applies. So in this case, movie table and the actor table, we have 3 tables in our database. And then a search condition, what other search condition applies. Okay, so this is a one way of doing that. Right, now let's come to a small topic. I think we have actually discussed this before, joining the tables. And now sometimes still the students probably, I mean, in previous semesters, they have a bit of a confusion. They keep asking this question from me because, you know, when you define the table, right? So when you create the tables, when we tend to define foreign key constraint, right? So we just write, okay, foreign key, blah, 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 references to table, something A or B or C, right? So, so then why we still need to use the inner join in the inner join command, that why we need to use that joining command or join these 2 tables, because current the Oracle or whatever the database management systems just go to the create table statement and see that a link, right? But we need to keep remember these 2 things are different things, right? So create table statement actually is something we establish foreign keys for referential integrity. So that means we need to check whether it's foreign keys and the primary key, so the child and the parent is matching, right? So that concept is quite different to inner joins, right? Inner joins basically we use we can join anything, any table. Sometimes some tables coming from totally different databases, right? So in that case, we need to match the 2 tables and see whether we can derive some information to make decisions, right? So that is the reason in the inner join, they have designed the inner join command in a way that we can actually access any or link any 2 tables in different databases where we can derive common information or whatever the information we need. So this is a classic example. So for example, now think about we have two tables, right? A product table and the worker table, and the say product table is coming from totally different database. Say think about maybe it's coming from our inventory table, right? And then we have a table called the worker table, maybe coming from our human resource management database. Okay, so management need a kind of a report, right? So now so they wanted to find out all the products and all the what is the product and the people who born in the products manufactured countries, right? For some weird reason the management need that information. So how can we connect these two? Because it's coming from two different tables, there's no relationship between these two tables, no foreign keys, etc., etc. So the only way we can use it, now you can see, now if you go through these two tables you can see the two columns in these two tables looks like have similar information, right? For example, in the product table we have a column called a country made, and in the worker table we have a table called born in country, right? So what we can do is now we can match these two columns, right, using an inner join command, right? Inner join command. So we can write a kind of a select statement, something like this. So these are the information the management required. Say, for example, they need the product ID, so product IDs are coming from product table, so we need to use alias, right? In this case, product is called P, so ID column coming from P table, and the description is coming from the pre table, and the worker's name coming from the other table called worker W, and then the born in country is coming from the W table as well. And then we use normally in the normal way from product P in a join W, and then we relate these two columns. In this case, it is not primary key and the foreign key, right? So here we just link the common column or common value columns, right, in these two tables. Okay. So you can do that like this. So that is the main purpose of inner join. It's quite different to create table statement, right? So that is the way. That is the reason why we again in the select statement link these two columns, right? So two different concepts. So that is what I have explained, I think, in this slide. Foreign key, primary key is actually a relational model concept, right? Relational model concept, because we need to establish that parent and child relationship. Remember the parent and child relationship, right? Each child has to have a kind of a matching parent, and then that's the reason we, when you try to insert something invalid foreign key, then you will get a kind of a error message, right? There's a no matching parent found or something like that, right? So that's a different concept. But actually inner join is coming from the set theory, right? Remember the set theory? Set theories means, you know, you are taking intersection or the common values between different tables, right? So it's actually it's coming from set theory, basically. So it's not necessarily the foreign key and the primary key. Right, so that's about that small bit. I just put a couple of slides there in order to show the difference between these two concepts. Right. Actually, I had a very big confusion when I start my, first database class. So I had that doubt as well. I thought I'll clarify it for you guys as well. Right, now let's go to this slide. Now we are coming to another topic. Actually, before that, let's go through this small. Actually, this is very important topic, I would say. Right now, we are going to a little bit more bit of advanced areas. So it's actually good to start from this small this example. Right now, let's think about these two tables. So we have a employee table and the branch table, right? So three columns in the employee table, right? and 3 columns in the branch table. So the employee number is the primary key here. Branch code is the primary key for the branch, right? And then there is a relationship, many to one relationship. So what do you mean by many to one here? So one employee must relate to one branch, and one branch may have many employees, right? So obviously the foreign key goes to the employee table. So the branch code, in other words, goes to the employee table as well. So in the employee table we have 4 columns, right? So branch code is the foreign key. So why I am telling this, we need to actually move to our next important topic. So in this case, you can see the foreign key goes there. So in this case, in this example, you can say there are 2 entities, right? 2 entities. We can actually define these 2 entities as a strong entity, right? So why I'm telling this one, because we need to categorize the entities that we are trying to build in our database into 2 parts, right? Some entities are strong entities, some entities are weak entities. So we need to classify any object or any place or person that we are trying to represent in our database into these 2 categories, right? So let's think about this, right? So for example, in the Swinburne we have many buildings, right? Like, I don't know, you haven't visited university yet. So we have a building called BA, EN, etc., different names or codes, right? BA stand for arts, arts building, or business and arts building. And then we have another building called EN building or engineering building, right? So it has a codes and the titles, right? So we can say the building entity that we are trying to represent in our database is a strong entity. So why I am telling why it is a strong entity. So strong entities are entities that can exist independently on the other entities. So that means, in other words, strong entities can define by itself. It can stand by itself without getting any help from other entities in our database. That's right. For example, in this case, we have its own identifier, building code, right? Building has its own identifier. So we can identify each instance in this this entity called building without having any trouble, because it has its identifier building code. Okay. But at the same time, we have weak entities, right? And now let's think about an example. And for example, think about entity called a room entity, right? So we have different rooms in university. So for example, room number 403, and then that room is a lecture theater, and it has we can put 85 students, or capacity is 85. So we have 85 seats. And also we need to tell, okay, which building this room is belong, because we may have another 403 in EN building or another building, right? So we obviously need to tell which room this room is belongs to, right? So this belongs to BA, right? But if you convert that into ER model or entity relationship diagrams, so we tend to have 2 entities like this, right? One for the building and one for the room. But here in this case, we are not actually showing the building code BA, right? But it implies because there is one major rule when you defining entity relationship diagram. So that rule is any attribute in any model, in a given model, in one model, only appears or must only appears once in an ERD, right? You can't repeat it again, okay, the same diagram, right? So it implies that if you want to borrow something from the other table to define the primary key, So it implies that we are, so there is a way that we can show how to borrow it, okay? So, but we are not going to show it in ERD. So, so room number, in the rooms, for example, in the room table, in this case, room number is not enough to define the primary key, isn't it? Because we obviously need to tell this room belongs to certain which building it belongs to, right? So so that means we need to actually have a we need to borrow this building code from this side to this side to define the primary key for the room, isn't it? Right? So building code plus the room number probably be the best primary key for the right. For example, BA403 or EN403 or something else. So because we have the multiple room numbers. So definitely it must be a composite identifier in terms of the room, isn't it? Right. So that means we are borrowing the part of the identifier, not the whole lot, right? Because we have the one part here, but another part we can borrow from this side to that side, right? But the thing is this, then we need to define the relationship, right? Obviously, right? So for example, one building may contains many rooms, right? That's the relationship. And the other way around, if you have one room, it must belongs to one building, right? So that is the kind of relationship we expect between the building and the room. So then now again you need to think about this part. So we have the many end attached to the room, so that means the primary key here coming there as a foreign key as well. But at the same time, we need to borrow the same primary key as part of the primary key of the room as well. So how are you going to tell? How are you going to show that that in your ERD? How are you going to show that you are borrowing part of the identifier from the other related entity? So we can show that by underlining the relationship line. Okay, so we underline. If you see the underline there, now you can actually go through your assignment and see whether there are any underlines in your with the given and ERD modules. Okay, so that if you have underlines, so that means we are borrowing something, right? So always, usually, as a rule of thumb, always at the many end, it tend to borrow the primary key or part of the primary key, or maybe sometimes we need to borrow the whole lot, right? Or part in this case because part is there, so we borrow the rest of the part from the other entity. So in this case we borrowed. So so we underline that. Okay. So always, as a rule of thumb, at many end where we are borrowing the identifier from the other end, right? Not the one, not the one end. Many end borrows the identifier from the other end, right? So remember this, okay? Always. So Chanel, you have a question. So the building code becomes the foreign key. Yes, that's right. Yes, very good question. Yes. So so in this case, building code is a part of the primary key as well. Building code is a foreign key as well. So that's the thing, right? So it has a dual expectation. I mean, role. The building code has a dual role. It's a part of the identifier as well as its foreign key as well. Okay. Right. So remember to underline. Right. So if you borrow something from the other side, make sure you underline the relationship. And one more thing that we need to do, if it is a weak entity, now this is the definition for the weak entities. Weak entity is an entity that borrows part of or all of its identifier, right? Part of or all of your identifier. So in this case, part, right? because part is already there. And the other important thing that you need to do is, if it is a weak entity, not only we underline the relationship, but we need to define, we need to actually change the way we draw the weak entity. So in this case, it will become a double outline entity, right? So see, this one is a single outline, here the double outline, right? So when you see that, when you see an EI diagram with a double outline, so you should know, all right, that's the weak entity, right? And then the other thing that you need to remember is, okay, right, that underline, so that means we are borrowing. So usually when you underline it, that means you need to double outline as well, right? Because you can't have a entity double outline without underline, right? Okay, so that means it's a weak entity, right? Right, so if you go through this diagram, this is the final version. So there are a lot of information actually tells in this diagram, right? So we can say the row, the building code has underlined. So that means that's the identifier of the building, as well as it's partially helping the room to define its identifier as well, because it's the relationship is underlined, right? And then the double outline means it indicates the room is a weak entity, right? So that means it borrows the part of the identifier. So in this case, the identifier also become the borrowed identifier also becomes the foreign key of the weak entity as well. Okay. So that's something that you need to think little bit, put a little bit head around, because this sometimes bit confused. Actually, it's not that big deal. If you do, I mean, let's do some questions in next week. Probably we'll learn this, right? Actually, it's a very piece of cake, I would say. It's very easy. Don't take too much stress. So it's once you solve the problems, you will realize it's easy concept. Right, so so I have here now a revised ERD relational model conversion. Now remember the steps I have given earlier. Now I need to a little bit modify, because now we have the weak entities, right? So the first step that we need to do is create the tables for the each entity, or create these boxes for each entity, and then attributes, define the attributes, right? And then identify the strong entities. Now, strong entities very easily identify, because the attributes, so the identifier itself will uniquely identify the instances in that particular table. So that means that entity is a strong entity. And then we underline the primary key in that strong entity, and then see whether and then the primary key will become the foreign key for the other entity, obviously, because it's at the many end, right? And then we need to think about whether it is underlined, right? If it is underlined, and then that means it's a weak entity. So weak entity means this borrows the part of that identifier to define its own identifier as well. So in this case, room is borrowing the part of the identifier. We need to double underline the both in our relational schema, right? But we are not showing it here, right? So don't repeat another building code balloon here, because it's wrong, because as I mentioned, the rule, it implies here we borrowing the identifier for the other side, okay? But in relational schema, we need to show that by underlining the both columns in our weak entity, right? And then say foreign key building code is referencing to building as well. So this is the final relational schema to represent this relational model. Okay. Here, right. So this is the same thing. Another graphically I'm demonstrating. So here the link. So the building code in the building matching the foreign key in the building code at the room table. So that's what it means here. Right, so that's something that I like to mention. And right now, let's go to another example. In this case, now remember, I think the week one we played with some tables, or the movie table, movie color table, and the rating table. Remember the movies database that we have created at around 304 movies, right? And ratings, and then movie colors. Right now, I am introducing another table. Right now, in this time, I am introducing a table called actors. Right now, obviously, movies has actors, isn't it? So here I have defined another table called actor table. So in that table, I got 4 columns, right? Actor number, first name, surname, and the gender, and then obviously actor number underline, right? Underline, that means that's a primary key. Now, if you go through this table, so we have actors like Jennifer Lawrence, Bradley Cooper, Hugh Jackman, etc. So, but by the way, don't send Facebook or Twitter message asking, "Are you actor number 89, Jennifer?" So don't ask that. This is just this that we have given our table, right? So it's not nothing to do with them. Okay. So so if you look at this table, obviously, what kind of table is that? Is it a strong entity or it's a weak entity? By the way, if you just go through this table, it looks like what? It looks like a strong or weak. Can this table stand by itself without getting any help from other tables? Right? Okay, what do you think about it? Strong or weak? Any idea, guys? What do you think? Is it a strong entity or a weak entity? Yeah, it looks like a strong entity. Yeah, it's a strong entity because why? We have its own identifier, right? So each actor has a unique number, right? Yeah, unique number. So that means it's a strong entity. This table can stand by itself without getting any identifier from the other end. Yeah, that's right. Right, so then we have the movie entity. Remember the movie entity that we have created last time, week 2 or week 1 or week 2, I guess, yeah. So we have movie numbers and title of the movies, each movie release years, run times, rating codes, and then IMDb scores, etc., etc. So in this case, movies looks like, what kind of table movie looks like here in this case? Is it a strong table or is it a weak table or is it a something else? Is it what is that? Looks like another a strong table, isn't it? Another strong table, right? Because each movie is unique, right? We have each unique movie number for each movie, right? Right. So now we have an actor, right? Then we have actor table, and we have a movie table, right? So now we need to know who is actually casting or acting in which movies. How are we going to produce sort of kind of, for example, we need to know, okay, right, Bradley Cooper, right? So he acted on a Silver Lining Playbook, right? So we can say, all right, actor number 220, that is my actor number in the actors in my actor table, right? And then I can say, all right, he has casted on movie number 41, which is the Silver Lining Playbook, right? At the same time, Jennifer Lawrence in my table is actor number 89, and she has casted in Silver Lining Playbook as well. So movie number 41, right? And also Jennifer is casted on Hunger Games as well. That's my movie number 15 according to my movie table, right? So if I want to kind of produce something like this, right? For example, actor number 220, 41, the movie number. Actor 89, that's a Jennifer. Movie number 41, 89, 15. That's again the Jennifer. It's Hunger. Um, uh, in something. Sorry, Hunger Games. Yeah. So now in this case, and see now, if you want to kind of develop a table like this, what kind of table is this? Can this table looks like now actor number is actually coming from actor table, isn't it? Because we already have that instance or that particular attribute in our database, right? So also we have the movie number attribute in our database. It's there in the movie table, right? So the actor number is there in the actor table, the movie number is there in the movie table, right? So if I want to produce another table like this, so this table looks like what? Is it a strong table or is it a weak table? What do you think? Is it a strong or a weak in this case? It's a weak table, isn't it? Why it is a weak table? Because we already have the actor number and the movie number. So in order to create this table, we need to borrow it. Yes, Molly. We need to borrow it, isn't it? We need to borrow the actor number from the actor table. We need to borrow the movie number from the movie table, right? So otherwise, we can't create this table, right? So looks like this table, I can give a name like it's my casting table, right? Or something else. Right? So so for example, now I'll give a name for temporary. It is as my movie actor table, right? Actor number and the movie number. So now if you think about this table, if you wanted to make a kind of a primary key for this table, can I take the actor number alone as a primary key? No, right? Because you can see the Jennifer Lawrence 89 is repeating, right? So it can't be the actor number, right? So can I take the movie number as a primary key? Of course, no, right? You can say the 41 means Silver Lining Playbook. So you can say Silver Lining Playbook 41 movie repeats, right? So the best primary key is we need to combine, right? You need to combine both columns to make it as a unique primary key, right? So actor number plus movie number in both will define an appropriate primary key in this case. So I just underline the both columns. Then if I put that table into our database, right? If I put that table into a database, my database now looks like this, isn't it? So I have one in an actor table, I have another in the movie table. So I need to borrow the actor number from the actor table. I need to borrow the movie number from the movie table. Okay, so that means the movie actor table in this case has a composite identifier, and then both has, so in that, sorry, the composite identifier, and both keys place as a foreign key, right? Because we are borrowing foreign key, sorry, with the actor number coming from the actor table, so that is my foreign key number 1, as same as the movie number is coming from my movie table, right? That's my foreign key number 2, right? So this is my foreign key number 1, this is my foreign key number 2, right? So if I actually put that into ER diagram, right? ER diagram. So now my ER diagram actually looks like this. This is how we design the ER diagram, right? So we have the strong entity movie, okay, and we have another strong entity called the actor, okay, and then I have a weak entity called movie actor, right? So I need to make it weak entity. Why weak entity? Because I'm borrowing movie number and I'm borrowing the actor number, right? So that means I need to underline the relationship names, right? So now see this, in this case there is no attributes by itself, so I have only 2 attributes, but both attributes are borrowed attributes from either side, yeah. But I have 2 foreign keys as well. So these borrowed attributes actually has a dual role. It works as a primary key for this entity, for this weak entity, as well as it acting as the foreign key as well, right? Right, so this is a kind of, so we can say this is one-to-many or 2 one-to-many type of relationships, right? So you can see there's a one-to-many here in the left side, and then we have another one-to-many in this right-hand side as well, right? Right. Now, actually, the lesson you need to learn here, I know it's too much of information, but The lesson you need to learn in this case is anytime if there is an interaction between two strong entities, obviously most of the time, around 60 to 70%, or I would say 80% of time, we have a weak entity between this interaction, right? Right. So, for example, if you say, okay, movies have many actors, right? And actors can cast in many movies, right? So there's an interaction between these two, right? So how can we show that interaction? By using a weak entities. Actually, what information, so we give a name, right? In this case, earlier I just give a movie actor the name, because sometimes it will happen, right? If you go to a different industries, guys, right? One industry, because you will work as a different IT, professional in different industries, so they have used different jargon, different names, conventions, etc., etc. So we need to reflect that in our tables, right? So for example, here the movie industry or whatever the entertainment industry, maybe we may not have any idea what this table's name, what is the table name. So in that case, what we can give actually temporarily, we can combine the names of the opposite tables to make it as a temporary table name, and then we can actually interview the users and say, okay, looks like it's a casting table. They call it as casting if the actors are acting in different movies, right? If you allocate these actors to different movies, so we can call it as a casting table, casting, something like that. That's the name they use. Okay, so I can change it. So yeah, so most of the time when I work in the industry, I actually come across these sort of problems, issues. So this is what I do. I just first combine, and then I once I create the model or logic in the model, then of course I can rename the VB tables very easy later on. Right. So now, if I put that two tables into our existing model, that we have created in week 2. Remember, the week 2 we have this part, right? So we have movies, we have ratings, we have movie colors. Now our model now looks like this, right? So we just attach these new two entities to the existing model, right? So in this case, you can see the existing our model got actually three strong entities in this case, right? Three strong entities, because each entity got its own identifier, right? And then the movie is a strong entity, right? But it's not borrowing anything, but it has two foreign keys pointing to the other directions of the strong entities. In this case, color code is coming here, and the rating codes as well, right? So two foreign keys, it's there. And now when you join this, the recently created these two entities, right? So why we have the casting? Because there's an interaction between this recently created actor table with the movie table. So we just created a table called casting. This is where we allocate all the actors in separate movies, so we can see which actors are casted at which movies, right? So we can easily get information. And then remember to underline the board direction, so that means we are borrowing the identifiers. Right, now if I ask a question, right? Say, imagine that we have created all these model and then converted to the relational schema. So which relations will have the foreign keys, and how many foreign keys in each relation? All right, now let's go through these questions. So let's go one by one. Let's start from the rating. Do we have any foreign key in the rating table? Do you have any foreign key in the rating table? Yes or no? No. Yes. Yeah. We don't have any, right? Do we have any? Okay, now let's go to the movie color table. Do we have any foreign key at the movie color table? Again, the answer is No, right? Yes. All right. Do we have the foreign key in the actor table? Again, the answer is no, right? Because there is no many ends attached to here, right? All right. So do we have foreign keys in the movie table? Yes, we have two foreign keys. One is coming from the rating and the other one is coming from the movie color, right? Yeah. And do we have the foreign keys in the casting table? Again, the answer is yes. We have two foreign keys. One is coming from the movie number, sorry, movie table, that's the movie number, and another one coming from the actor table, that's the actor number, right? Right, so two here, one there in the movie table. Okay, right, so that is what it shows here. So we can now convert the relational schema very easily because now we know the link. So don't worry about that. In your final actually tests, not the assignment. I just in your final test, I'll give you a small case study, and then I'll ask it, okay, draw this kind of model, right? So you need to know whether a particular entity is a strong entity or particular entity is a weak entity, right? So how are we going to distinguish strong entities and weak entities? If an entity has its own identifier, you can define its instances by using its own identifier. That entity is a strong entity. If an entity can't define by its own identifiers, if it is depend on the other entities to define its identifier, so that entity will be a weak entity, right? So that is how you distinguish these two. It's not so easy. I would say it's not so easy sometimes, but practice will make it. You need to have practice, right? When you practice it, then you can easily identify, right? So I'll ask you to. I'll give you a brief business narrative. I will ask you to identify strong and weak entities, specify the relationships, and then construct the relational schema, right? This is your final test. Remember the two tests. Now the first test is coming on in week 6. Now today is week 4, another 2 weeks time. So I think I have sorry, I forgot to mention, I have made available 2 practice tests. So if you go to the module section, I think the second or third module, or second module, I guess, there is a module called practice test. There are 2 practice tests. So if you want to do more, actually, even if you do tutorial questions, I believe you can do a lot of stuff in the test. But if you want more, there are 2 practice tests. But unfortunately, there is no answers. Maybe you can post some messages asking other colleagues help. Otherwise, you can ask from me during the tutorial time. Okay. All right. Right, so you know the pattern now. Now you know this model, right? So we have weak entity. Now this is kind of a pattern. Actually, you can see exist in many instances, in many different scenarios, in many different industries. Sometimes these one to many type of relationships. Right. For example, now let's go through. Now you know this one. This is what we have done just now. So if I actually now if I ask a question, what is the purpose of creating this so-called casting entity? The reason why we create the casting entity is to allocate movies and actors, right? So it allocates movies and actors. Then we can easily say which actor is casted in which movie. That is the main reason, right? The main reason. Sorry, Kunjal, can you hear me? So because you made a message saying you can't hear me. Can the others hear my voice? Sorry. Is it clear? Hello, can you hear? Yeah, you can? Yeah. Okay. Sorry, Kunjal, I can see your internet connection is dropping because I have a kind of a meter saying indicating your connections. it says sometimes red. That means your connection has a, can you move into a bit closer to your Wi-Fi modem or somewhere closer to that? Probably that might be the reason. Okay. Okay. Right. So yeah. So this is one example, and the same pattern actually can exist in. By the way, guys, I forgot to mention one more thing. Now, if you think about this particular model, right? This model. What if I ask a question? What which entity is most important? Do you think for this particular business? Which one do you think? Is it the movie entity more important, or act entity, or casting entity? What do you think? What is the most important entity? Just think about it. Which one is the most important in this? For example, if I run a kind of entertainment company, right? Which one do you think I am more interested in order in terms of a movie as so yeah, obviously movie, but in terms of my money wise, which one? Maybe which one do you think? Movie and actor? I would say it's casting, right? Casting, because it shows me how many or which actors are in which movies, right? And then the that actually give you the most important information, right? Yes, movies we have the movie list, we have the actor list, but weak entities give the most important information, right? Which movies have which actors are casted in which movies. In that case, I can actually, maybe I can plan my cost, right? So how many cast more actors are casted in which movie, what is my budget, how much I paid, etc., can be determined by this weekend, isn't it? Because this is where we allocate everything, right? Movies and actors are, if you have another strong entity, we can allocate something else to this as well, right? So that weak candidate actually gives you the more important information in terms of maybe the decision making purpose, right? So the lesson you need to learn is when the when the entity becomes weaker and weaker, you will learn some more, right? Some entity becomes weaker and weaker. That entity typically records the most important information, right? That is the lesson you need to learn, right? Because more the granular the information you record, right, more the value you can derive from that entity, right? um, right, so just keep that in mind, okay? But we'll come to this stuff a little bit later on, maybe other lectures, so you will realize that, okay? Right, so we allocate the movies in this case to special allocate the actors to different movies by using the casting entity. That is the major reason why, or major purpose why we have this casting entity. Right, so same pattern actually can exist in other situation as well. For example, in this case, this is a university. When think about our own university, Swinburne, right? So we have a different subject. So we have a subject entity, right, with subject codes and subject names and credit information or whatever, right? And then we have the students entity. So your information all recorded in the student entity, student IDs, first names, surnames, contact details, etc., can be recorded there. And then we can have the enrollment entity, isn't it, right? So in the enrollment entity, what is the purpose of enrollment entity? We are allocating subjects to different students, isn't it, right? For example, in this case, you can see I have here some sample data. We have bunch of subjects and bunch of students here. And here in the enrollment entity, like what we did the same thing in the casting, right? Here the same thing, right? Same thing in the casting. What in this case, I allocate students to different subjects, right? So what is the purpose of the enrollment, the weak entity enrollment? Because the purpose is to allocate students to different subjects. So that is the main purpose. That is what it does, right? So in this case also, what is the primary key for the enrollment entity? Again, the primary key is determined by borrowed identifiers from the either side, right? So we need to borrow the subject code, we need to borrow the student ID, then we can define the primary key as subject code and the student ID in both, right? And also a subject code and a student ID acting here as a foreign key as well, right? Foreign key as well. Yeah, so that's what I described in this particular slide. So you can see different students are enrolled in. For example, Jane Taylor is enrolled in database subject, as well as she has enrolled in programming VB.NET subject as well. So that's what it shows in this table. So you can't enroll. There is a problem actually in this model, right? There is a problem. We will learn these problems later on, because we need to first learn the basic. The problem of this model is if this student, for example, fails one subject in this semester, she can't enroll again, isn't it? Because we can't repeat these two combination again in the same table, right? So how can we avoid that sort of problems in databases, right? You will learn it, don't worry, right? Because at this moment, think about this problem. How are we going to allocate students to different subjects by creating an enrollment week entity, right? So just think about it like that. So the same pattern happens in another situation. Now this is another situation. This is a library, right? But in this case, quite a little different, because you can see we have a attribute sits in the loan entity. So because now, what do you mean by the loan entity, by the way? So we have in the library we have books, right? And then we have people, patrons, I would say. Actually, a good word is patrons. So the patrons are borrowing the books, right? So that maybe that then we have an entity called the loan entity, right? Because the loan entity's main purpose is to allocate, or we need to find out which person borrowed which book, right? And then in this case, we have a date, right? Date, but it underlined. What do you mean by the underline in this case? So this is a still weak entity, right? But it has its own part of its own identifier, right? Called date. But same time it borrows identifiers from the other part of the identifiers from the other ends as well, right? For example, here book ID comes as this side, as well as person ID comes from the other side as well. So the identifier for the loan is now book ID, person ID plus the date. It has the date as well. The why I put the date, because you know the problem here, right? Here is the problem is because if you put the semester date, then we could have been overcome that problem, right? The same problem happened here. That is why I put the date here in this case. Now think about this person 1005, Lau James, right? He borrowed the book called How to Program, right? And then you can see he also or she yeah, he also borrowed the same book in another 13th June, right? 13th June again, right? So if you don't put a date, so what will happen is we can't allow him to borrow the second time the same book, right? So that is the reason we have a separate attribute date and then underline, right? So in this case, the primary key is a combination of 3 columns, right? 3 columns: book ID, person ID, plus the date, right? So what is the purpose of the weak entity? This loan weak entity, what is the purpose? To allocate patrons to each borrowed book, right? That's the main purpose. So what is the main for the library perspective? What is the main important entity in this case? I would say the loan, right? So in that case, in this example, what is the main entity for the university perspective? That's the enrollment. This determines their fees, income, isn't it? Right? Number of enrolled students, right? Can determine these from here, right? And here also the same, right? The loan, right? This actually determines the books borrowed, if the person didn't return it in a specified date, then they can determine the fees they charged, right? So likewise, weak entities are more important than a strong entity. But identification of weak entity, identifying the weak entities are quite challenging. Yeah, so here just I explained the same thing in this slide, so just you can go through later on. Right, so I have a question for you. Right now, imagine that you have this model, right? You have this model, right? So I need the answer. So answer asking is, what is the identifier for the entity X? This is entity X. So is it the answer A? Is it the B? Is it the C? Or is it D? Right, I'll give you 1 minute. Just think about this model, right? Think about what is the strong entity, what are the weak entities, right? And then I answer this question. So I want the identifier. Which identifier? What is the identifier for X? So 1 minute. So I want everyone to answer that question, right? Think about it. So Liam says C, Shena says A, Shangmin says A. How about Kunjal, Jun Hattori, Molly, Vanessa? Vanessa, you are very quiet today. Sia and San Chen Hu. How about others? Think about a little bit. I'll give you time. So what is the identifier for entity X? Molly, think about, okay, right. X is what? Now the first thing is first thing first. You need to we need to distinguish. Well, you need to clarify what kind of entity is X is. Is it a strong entity or is it a weak entity? Right, Molly, that's what you need to clarify first. Okay. So once you clarify that, so if it is a strong entity, then do I need to borrow anything? No, right? Do I need to borrow? No. Strong entities are not borrowing anything, right? It borrows only the foreign keys, of course, but not primary keys, right? And then if it is a weak entity, it borrows the identifiers, right? Then the next question is, which side of the identifiers I am borrowing? How are you going to determine which side I am borrowing it? If it is underlines, that means from that side I am borrowing the part of the identifier, right? So now let's think about that in that direction. So Molly, you say C, yes. Shena, now you change your answer, okay. C, right, good. How about Vanessa? You are so quiet. Vanessa says C. How about others? June, you are so quiet. No, June says where? C. Yeah, June says sorry. Yes, the answer is C. Answer is C. Why it is C? Well, now let's actually unpack this, right? Right. So X is what? X is a weak entity, right? Because it's a double outline, right? It's a weak entity, right? And then other thing actually I need to think about. Okay, now we have two attributes, right? All right. One attribute is underline. So that means since this is a weak entity, we need to borrow. We know that. But at the same time, we have part of the identifier existing that entity, right? Then the next question is from which side I need to borrow the identifier. So you can see there are three connections, right? Three connections, right? So if you go to this side, right hand side, why it doesn't underline, that means I'm not borrowing anything. Then the other one, there's no underline there, I'm not borrowing anything, but still we have getting a foreign keys, that's something else. But if I go to the left side, it underlines, so that means I'm borrowing WID. So that means the identifier for X is WID plus XID, right? So the answer is C, right? The answer is C, right? So that is how we need to determine that. Okay, is it clear? I think it's clear, right? All right. All right. So always think about the underline. That's really important, right? Okay. Right. Now we are moving to a different ball game. A different now forget about whatever we learned. So now we are coming to SQL stuff, right? So each week we are going like that. We do some part of SQL. We are doing some modeling part, ERD parts, and that's how we go, right? Right. Now forget about the ERDs. Now let's think about SQL, more technical stuff, right? Aggregate functions, right? So in SQL, we have a type of functions called aggregate functions. So why we need the aggregate functions? Because sometimes we need to aggregate some information in our tables, right? For example, we need to aggregate some numbers, or we need to add some numbers, or we need to count how many rows we have in that particular table, right? Or we need to sum up the particular column and see what is the total fees that we have collected, or we need to find out what is the average of particular fees we have collected, right? What is the average cost? What is the maximum cost? What is the minimum cost, etc., etc. These are called the aggregate functions, right? So aggregate functions are used almost always we use it with the select clause. You know the select clause, we define the columns, right? We define the columns. If I want to pick some columns from certain tables, we specify the columns, right? So in the aggregate functions also place inside the select statement, right? Now remember what do you mean by the function, by the way, guys? How to define the function? Usually when it comes with the kind of a brackets, that's a function, right? What is the purpose of function? Normally in any programming language, function returns some values, right? Function returns some values. Okay. So the same purpose applies to aggregate functions in SQL. In the aggregate function, actually, it applies to number of rows in a column, right? For example, if I want to count how many rows in a particular table, I can use a function called a count function, right? For example, if I want to count the whole how many tables in a particular table, so how many rows in a particular table, so what I can say is a count, and then inside the bracket I can put the asterisk mark. Remember, asterisk means the whole table, right? So I can place that count function in a select clause, right? Select clause, and I can run the SQL command like this, or select count everything, right, from the movie table. Okay, from movie. So that means it counts the total number of rows in my movie table. Remember, around 304, 308 movies we have in our table, movie table. So your answer looks like this, right? So we'll get a heading like this. So that is the heading of that count function, and then the number of movies that in that table, or the number of instances in that table. So the count function, and then we can actually play with the count function. We can actually play with these aggregate function by putting clauses like where clause, right? So the where clause actually restricts restrict the rows that we need to focus on, right? That is the restriction. So anywhere you play the restriction, it focus on the certain in that particular restricted area, and in this case, so here I am counting number of rows in my movie table, but I want only the movies released on the year 2004, right? So I restricted the release year equal to 2004, right? But I still need the whole focus in the whole table. but only release years 2004. So the count is 11. So I have 11 movies released in year 2000. So that is what we mean by this. The same time I can put some ands and nos or whatever the operators I want. So in this case I use the and command. I want the movies released between 2000 and 2009, right? So I just use the and command. So the count number of movies released 37. Sometimes what we can do is inside the count command we can specify the name of the column rather than the asterisk. So if I specify the name of the column, then it counts, it focuses on that particular column, right? But only counts the not null cells only, right? Not null cells. Remember the not nulls, sometimes we have null values in certain cells, right? So if I want to focus only not null cells, so we can put the particular column inside the count function, right? And now see, that's what I'm telling you in last couple of weeks or so. Say if you have nulls, then alarm bells rings, right? So always you need to make sure that minimize the null values. I really, that's a big problem for any database nulls. But sometimes we can't avoid. We need to because if the business rule says you can allow the null values, then we can't help with it because we need to leave it. But most of the time we think about just remove the null values, right? Yeah, so this example counting the gender, the total genders, how many have in our company in the gender column, but not nulls, right? And then here in this case, I'm counting the total employees in terms of the gender, but I want the people who resides in my Hawthorne branch, right? So I just put that condition inside the where clause, but still focusing on the gender column. So likewise, I have some other aggregate functions as well, right? So these are the popular aggregate functions apart from the count function. So we have sum function, average function, minimum function, and maximum function. So sum means we need to, if you want to get the total dollar value or whatever dollar amount or what is the sum, so it's a sum function. Count actually counting number of rows, okay? And then average is average. If you want to find out the average value of a certain column, I can use the average. Minimum means minimum, right? If I want to find out what is the minimum value in that column, okay, I can use min function. Max is the other way around, so maximum value in a particular column. Now remember, when you use a sum, average, minimum, and max functions, you must specify the column name, right? Because it doesn't make any sense if you don't specify any column if you use these functions, because we need to focus in a particular column in order to calculate average, in order to find out minimum value, in order to find out maximum value, in order to find out total sum of the total value, right? Of course, the count function doesn't want that because we can count the number of rows in the whole table, or maybe we can focus on a certain column, right? Doesn't make sense to put any name. Right, so this is how we use. So this bunch of examples. So remember, each aggregate function, we need to place it inside the select clause, right? So in this case, I am calculating the total sum of run times from the movie table, and here I am calculating the average value of the runtime column, minimum value of the runtime column, maximum value, and total runtime. But in this case, I have the where clause restriction. I want only total runtime for the movies with the title Hamlet. The last one, I'm calculating the minimum runtime value, but I need to focus only the release years 2005 only, right? So you obviously sometimes, most of the times actually, when we use the these aggregate functions, we tend to use it with the round function. Round function is not an aggregate function, by the way. It rounding the numbers, because sometimes when you run a kind of a, say for example, this sort of query like I want to calculate the average runtime of my movie column, you will get a very ugly number like that, too many decimal points, right? So I don't want that to happen, right? I want only 2 decimal points, right? So if I want to put 2 decimal points only, I can wrap the function with another function called the round function, right? So inside the round function, I put this function, average function, and then if I want how many now, if I want the decimal points, I can put in how many decimal points I need. In this case, I want only 2 decimal points. I just put 2. So this is my answer. If I don't want decimal points, just ignore the decimal places, because it's not mandatory. So you can just put the average function inside the round function. So you get the nearest whole number converted. So output looks like this. Right, so that is about the aggregate, and then the special rules. Now that is the things that we need to learn. What are the things? So in when you use the aggregate functions, right? So you know that aggregate functions need to be placed in the select statement, right? Because sometimes the select statement, when you write a select statement, you may need some other information in your report as well. It comes from the other columns, with not necessarily the aggregate values, right? So in the aggregate, in the select statement, you can have two types of expressions, I would say, right? I can have a non-aggregate expressions, right? Like title, runtime, release year, etc., etc. And I may have an aggregate expressions in the select clause, right? Like average, minimum, sum, and count. So if I place aggregate expressions and non-aggregate expression in the same select clause, I need to be a bit careful, right? Because then I need to use a special clause called group by clause, right? Now, for example, in this case, so what I wanted to do, I wanted to produce a report. I want to produce a report saying, okay, what is my release years, right? What is my release years in my database? I want to find a total number of movies released in each of these years, right? So how can I produce a report like this? So obviously, you know, I need to use the count function, because I need to count number of rows which matches with each year, right? So in order to produce this, definitely I need to have a select statement. In that select statement, I have the non-aggregate expression and an aggregate expression, right? So that means I need to group the number of counts with the non-aggregate expression. In this case, according to the release year, right? So the produce has to be grouped with the release year. Okay, so I need to use group by clause in this case, right? So here select release year count, right? So this is the first column, this is the second column. So it's counting the number of rows from the movie. Then I says, okay, group by according to the release year. Okay, so this then what happened? This count, group it according to releases. You must actually place this clause if you have the non-aggregate and aggregate actions in your select statement. Okay. So in this case, the same. Here I am focusing on my movie table here, but I want to find out the number of movies for each rating codes. Now remember different rating codes we have in the movie table, right? So in this case, it counting number of movies in each rating code. So group by a rating code. Okay. So always a non-aggregate. So you need to put the non-aggregate expression as a group by clause. So here in the non-aggregate expression is rating code. So the group by clause also rating code. So early example, non-aggregate expression is release year, so the group by close is the release. Okay. So this is another example here. What I'm doing here. Okay, so here I'm calculating the average runtime. Okay, average runtime. So according to the release here. So again, non-aggregate expression with an aggregate expression. So I need to use a group by close with the non-aggregate expression. Okay. So I'm calculating the average values of each year. What is the average runtime value of the each year? In other words, right? So remember, if when you use other aggregate function other than count, you need to specify the column name, right? So I'm focusing on the runtime column. What is the average runtime column for each release year? So you can see this release here in the random order, right? So then I can actually build, you can put some more clauses here. So for example, I can order it by according to different order. Okay. So now I am putting another extra one, order, you know already, order by clause, right? So we have done that. So I can put the order by clause. Now in this case, I want to order it according to the release year order, but the descending release year order. So I just put order by rel year DESC. But sometimes I can order it by according to the average that we have calculated. I want to have ascending average order, so the smallest come first and the highest come are the last. So I can say order by according to this column order. So that is the second column. So I just specify the same thing here. And then you don't need to actually put ASC. That ASC stands for ascending. Default is ascending anyway, but you can say put that if you want, ASC. Right. Sometimes we can put the column number as well. If the expression is bit long, we can put the column number order as well. Like here, order by to descending order. So 2 means the second column order. Okay, that's also okay. Now in this case, now this is a bit complicated. Sometimes, now imagine I need to produce a report, something like this. So I want a report like release years, right? And then I wanted to have a rating codes in each release year. And I want to find out how many movies released in each year according to the rating code order. So how can I do that? How can I produce a report like this? So then you need to now think about, right? Now here in this report, in order to produce report, I have 3 columns. 2 are not non-aggregate, 1 is aggregate, isn't it? Right? So 2 non-aggregate, 1 aggregate, right? So that means definitely I need to have a group by clause, right? So so how do we write that? So how to write the group by clause in this case? So I write the normal select statement, select release here rating code. I want to count the numbers of for the whole table, right? So I just put count asterisk, right? From the movie, but I wanted to group it according to like this. First group it according to the release year, and then according to the rating code. Okay. I think I can put the vice versa as well. I can put first group by according to rating code and then the group by release year as well. I think I can do that. And then I can put the order by clause as well if I want to order it by according to specific order. So in this case, release first order it by according to the release year, right? Ascending order, and then rate according to the rating code, alphabetical order, right? Right. So, for example, think about this example. Now we are going to a little bit further down. So think about this example. Imagine I am producing a report like this. I want the release years and the number of movies in each release year. You can see there are small numbers, right? So our manager doesn't actually interested in it. He says, okay, Ravindra, please get rid of small. I am not interested in because some years we have only just one movies. We don't want that, right? I want a movies really maybe more 5 years which has more than 5 or more than 6 movies released, right? For example, more than 5 movies, 5 or more movies. So how can I restrict this, right? Because now I need to put a restriction here, right? In this case, okay. So how can I put? Can I use the where clause in this case, or something else? Okay, that is my next question is, right? So how can I get rid these small numbers count now here? Now think about this example. If I want to restrict something, right, now this restriction applies to not the row, right? It's not applies to the row in the table, but it applies to the aggregate values that we have calculated, right? So that means if we use now the where clause that we usually use for the restriction applies for the rows in the table, right? Rows in the table, right? But in this case, the restriction actually applies to the aggregate values that we computed, right? So that means we can't use the where clause, right? So that means we need to have another type of clause for that restrictions. So that clause is called a having clause, right? Why we use having clause? If I want to put a restriction for an aggregate values, okay? Right, so in this case, I want to produce a restriction for the count function. I don't want movies releasing less than 5, less than 5. I want greater than or equal to 5. So this is how I write the query. I use as normal select statement, right? So select release year and the count, okay, from the movie table, but according to group by according to a release year. But I want to put a restriction now. I want only or having, right? That is the keyword having the count this greater than or equal to 5. Right, greater than or equal to 5. So my result set now get like this. So it's completely different to the result set that appears before, isn't it? So now it's restricted. Okay, right. But still I can use the where clause. So why I'm using the where clause, by the way? Now in this case, this is a classic example. Now let's think about where clause, right? So think about this example. I want the movies released in each year and the rating codes, and I want to find out the count number of movies in each of the rating codes. So how many movies we have released in each rating code. But I don't want movies. I want actually movies in between 1990 and 1993, right? So in that case, I need to use a where clause now, right? Because I need to put a restriction in my table where this information is deriving, right? So I need to focus the oracle's attention into certain columns only, or sorry, certain rows only in my table, right? So I can put a where clause in this case, right? So select, right? I use normal select clause with the aggregate function from the movie, and then I tell, okay, please focus only on certain rows. So what are the rows I want? Where the release years greater than or equal to 19 and release year less than or equal to 99. I want the release years between movies between these 2 years, right? Then I put the group by release year, and then in this case group by we had 2 non-aggregate expressions, right? Release year and then the rating code. First release year and then the rating code, and then order by. Okay, so again now we can see here in this case, oh, I have small aggregate values. So some rating codes got only 1 movie. So my manager, no, I'm not interested in that. I want something more than maybe 2 or more than maybe 3 rating code, right? Then what? Then now I need to put another restriction on what? Aggregate function, isn't it? Right? Aggregate function. So that means I need to put the having clause. Okay. Now the having clause, now that is what sometimes people are making mistake. Having clause has to come after the group by clause, right? Once it group by, then put the having clause. So having count only greater than 1. I don't want any count less than 1. I'm having the count, that is the aggregate function, having the count greater than 1. Right. So this is my full query now, right? So first select statement, right, with the aggregate function, two non-aggregate expressions from the movie, and I put the restriction on the rows I wanted to focus on, right? And then I group it by according to non-aggregate, according to non-aggregate expressions, and then I want to tell Oracle, can you please give me only the counts or the aggregates greater than 1? Then I can order it by whatever I order I want, right? Now see the flow of instructions, right? Select from where, group by, having, and then the rest, right? Yeah, so when you write the expression or the SQL statement with the aggregate functions, sometimes students make, actually I made a lot of mistakes in my early days, right? So you will make the errors, don't worry. I forgot to put group by clause, right? So whenever, now think about it, whenever you get aggregate function in your select statement, always remember to put a group by clause with the non-aggregate expression. With the non-aggregate expression. If you have one, put one. If you have two non-aggregate, put two non-aggregates there. But make sure that there has to be a logic, right? You can't put lots different columns in a combination and try to get it, because it not make sense sometimes, right? So here also, logic comes at the which you think about your table, think about the columns. Can these two columns can aggregate? Can we put an aggregate function on there? Otherwise, it not make any sense, right? So yeah, so if you get an error message something like this, that means you need to know, I missed the aggregate clause. Oh, sorry, group by clause in this case, group by clause. Okay. Wow, that's the end of our lecture, right? So 61 slides I have covered. So any questions, guys? I know I went a little fast. I'm not sure whether I went very fast in the last few things. But the lesson is now aggregate functions. By the way, why we need aggregate function? Who is using the aggregate functions? These aggregate functions. Who is in the companies usually use aggregate? Is it important for operational levels? I don't think so, right? Operational level stuff like people from the Woolies or Coles, they are scanning your products, right? So they just record the information. They don't care about the aggregate, isn't it? Of course, sometimes you need to calculate total, but aggregate functions usually helpful for people in the higher hierarchy, in the higher order, people who are making decisions. They need more aggregate information, right? Sometimes we need to aggregate billions of rows. Imagine a bank, right? How many rows we create within 1 week in a certain tables, billions or trillions sometimes, right? So we need to run aggregate functions, right? So you will learn actually how we going to. I'm not actually going in detail, but in later stage in the semester, for the people who using more business intelligence type of data, like these aggregate function, they need to actually have a different type of databases. So the databases now we are designing, actually predominantly this subject is focusing on transactional databases, right? Daily transactions, right? But people who are using more aggregate stuff, right? Decision maker, they need a special type of database called data warehouses, right? So we'll learn those stuff a little bit later on, but we are not going to very deep. It's a very complicated area. So once you actually learn all these stuff, it's a piece of cake, right? So if you go to the higher education, there are special courses or special units which focus on more business intelligence, how to build warehouses, data marts for the decision makers. Their schemas are completely different. It's a different ball game, I would say, when you compare to transactional type of database.